Okay, today's topic is equivalent expressions. Equivalent expressions. Equivalent is a fancy word for equal. So we're talking about expressions that are equal to each other. Okay? So let's say we had 3x plus 7 plus x. And we wanted to simplify that. Well, first of all, let's talk about some of the parts of what we've got right here. This is an expression, and we have three separate terms. The terms are the different parts that are separated by either a plus sign or a minus sign. So 3x is one of the terms, 7 is a term, x is a term. These are three different terms. Two of them have variables, and the number in front of the variable is called a coefficient. So on this one, the coefficient is 3. On this one that has nothing there, we always assume the coefficient to be 1. So if there's no number in front of an x, we assume there to be 1x. So this has a coefficient of 3, this has a coefficient of 1. Now this number is called a constant. Constant is a number that does not have a variable. So 7 is the constant. So we have three terms. One of them is a constant. These two have variables, so they both have a coefficient, which is the number in front of the variable. Now, the key to understanding equivalent expressions is to know what like terms are. Like terms, terms that are alike. Like terms are terms that have the same variable. Okay, terms that have the same variable. So like terms here would be the 3x and the x. Like terms are the ones that you can actually add together. So if we wanted to simplify this, we could add 3x plus x. Remember, x means 1x. So 3x plus 1x is 4x. Now, we also have a plus 7. We can't combine this with the 3x because it doesn't have the same variable. There's no variable here. There's a variable of x here. So I'm just going to write plus 7. So I've simplified 3x plus 7 plus x into 4x plus 7. I've added my like terms, and anything that was not alike, I just included it on the end. So if I had 4a plus 3b plus 7a minus 2, let's think about that for a minute. There's 4 different terms here. Which of them are like terms? That's right. The ones that have the a's can be added together. So we have 4a plus 7a is 11a. There's a 3b here. Are there any other b's? No, so we will just put plus 3b. Are there any other constants? No, just the minus 2. Now since it's a minus, I'm going to put minus 2. Because there's a minus sign in front, I'm going to keep that in front here. So this is as simplified as we can get on that particular problem. All right. Now, combining these like terms applies to adding. You can multiply unlike terms all you want. So here we have 4 times 8x times 7. To multiply like terms, we're going to multiply our coefficients and our constants together. So we're going to do 4 times 8 times 7, bring the x to the end. Okay, so 4 times 8 is 32 times 7 times x. 32 times 7 is 224 times x. And just to finish it off, I'm just going to take this multiplication sign away. 224x. So that's how we combine terms with multiplying. Multiplying, you can combine all you want. Okay, now, let's say we had this problem. 14x, oops, more like 14x plus y plus 10x. Okay, so parentheses usually means you do this first, but can we combine 14x plus y? No, they have different terms. We have an x, we have a y. But what if we combined 14x plus 10x plus y? Remember, we talked about some of our properties, and that means you can change the order of some things as long as it's adding or multiplying, not subtracting or dividing. Here we can combine those two terms. 10x plus 14x is 24x. I'm going to bring down the plus y, and that's as far as we can get on that one. Okay, we can also use the distributive property with these problems. So let's say we had 4 times 2x plus y. Now, again, normally we do what's in the parentheses first, but we can't because there's an x and there's a y. They have unlike terms. So I'm going to use the distributive property to do this out. So I'm going to do 4 times 2x. 4 times 2 is 8x plus 4 times y, 4y. Can we combine these last two terms together? No. There's an x and a y, two different terms. So this is our final answer on that problem. Okay, one last thing. This one's a little trickier. We're going to do what's called factoring. And we're going to factor 36x plus 18y. To factor, we're looking at numbers that will multiply into both of these, or will divide evenly into both of these. So let's look at our coefficients first. We've got 36, we've got 18. What number will divide evenly into both of those? Well, I can think of a lot of numbers. 2, 3, 9, 18. 18 is the highest, so that's the number I'm going to do. So I'm going to pull the 18 out front, and I'm going to say 18 times what is 36x? Well, 18 times 2 is 36, and bring the x along as well. Plus 18 times what is 18y? That would be y. So I've just factored 36x plus 18y. We're bringing out the greatest common factor in front, 18, and put the rest in parentheses. Let me do another one just so we know what we're doing here. Let's factor 24x plus 8y. Okay, so we need to figure out what number will go into 24 and 8 evenly. Well, what's the largest number we can think of? Because certainly 2 will go in, 4 will go in. How about 8? 8 works. 8 goes right here. 8 times what is 24? 3x plus 8 times what is 8? 1. 1y is just y. Now, sometimes we might even have something else we can pull out. What if we had this? What if we had 12xy plus 3x? Okay, well, what number will divide evenly into 12 and 3? Well, that would be 3. But if we look at variables, this has an x, this has an x. So I'm going to pull the x out in front as well. 3x times what gives us 12xy? Well, 3 times what is 12? That would be 4. I already pulled the x out, so that leaves just the y. 3x times what is 3x? 1. 3x times 1 is 3x. So this is factoring this one that has a variable inside. All right, there's a lot here, so don't hesitate to ask if you have questions.